This is video 3 of a factoring strategy. We're continuing with some more examples. So remember, we're going to ask ourselves a list of questions to see how we're going to factor each of the problems we've been presented with. So looking at number 6, the first thing I'm going to ask myself, which remember is always your first question, do I have a GCF? I don't in the variables because I have an x squared and a y squared, but I have to figure out whether 121 and 36 have any common factors. Well, 121 is the square of 11, so the only factors I have in that are 11, and 11 doesn't divide into 36, so that means I don't have any common factors. There's no GCF on this problem. So my next step is to ask myself, how many terms do I have? This has 2 terms, and when we have 2 terms, remember we're looking for it to be a difference of 2 perfect squares. Well, the first term is a perfect square and the last term is a perfect square. They both have square roots. But the middle term is a plus sign, not a minus sign. And remember, when there's no GCF, the sum of 2 perfect squares is always prime. That means that binomial cannot be factored. Okay, looking at number 7. First question I ask myself on every factoring problem, is there a GCF? I look at x squared, x, and -6, and there is nothing in common to all those 3 terms. So again, just like number 6, there is no GCF to factor out. You're not always going to have one, but you always have to check it as a first step. So, don't have a GCF. The next thing I do is count my terms. I have 3 terms. Remember, with 3 terms, the first thing you want to ask yourself is, do I have a perfect square trinomial? Well, the first term is a perfect square, but the last term is not. 6 does not have a square root, besides which it's negative, and you can't have a square root of a negative number in the real number system, so it's not a perfect square trinomial. So then I'm going to go on to the t-chart. I don't have a leading coefficient other than 1, so that means I'm just looking at the last number, -6, and the coefficient of the middle number, which is +1, and I'm looking for 2 numbers that will multiply to -6 and add to +1. If nothing comes to you right away, write down all the factors you have possible. Remember, this t-chart is only necessary if the numbers don't come to you right away. So I have 1 and 6 and I have 3 and 2. Those are my 2 possible combinations that multiply to 6. They multiply to a negative, which means one of them had to be negative and one had to be positive. And I need the combination of 1 negative and 1 positive number to add up to +1. If you have one of each and they add to a positive, of course, that means the bigger of the 2 numbers is positive, the smaller of the 2 numbers is negative. So there's my small negative and there's my small negative. Now, adding -1 and 6 does not result in a +1, so that means it's not that combination. Adding 3 and -2 does add up to +1. So that's the right combination. And now remember, because I have no leading coefficient, I don't have to use grouping. I can just use my numbers 3 and -2, take the square root of the first term, and follow it by those 2 numbers. That means I have x plus 3 and x minus 2. And that's fully factored. I look at both parentheses. I don't have any GCF left in them. Neither one of them is a difference of squares. So that is my factorization of x squared plus x minus 6. Okay. Looking at number 8, I have a 4-term polynomial that I'm beginning by looking for a factor in common to all of those terms. So I have an x squared in the first one, I have an x squared in the second one, but my third term, ym, has no x's in it, so that's not in common to all the terms. Next I look at y. I have no y in the second term, so that's not in common to all of the terms. And since neither one of my first 2 were in common to everything else, then that means I don't have a greatest common factor. I don't have to look at the other ones because they won't have been found in the first term. So that means I'm ready to count my terms, which I already did. I counted 4 terms, and if it's 4 terms, we're looking to see if we can factor by grouping. So remember, when you factor by grouping, first start out with the combination of the first 2 terms and look for a GCF amongst those 2 terms. Well, I do have one. It's x squared. So I factor out the x squared, and that leaves me y plus z squared. Remember, what I did was say x squared divided by x squared cancels, so I was left with a y in the parentheses. Then I said x squared in the second term canceled with the x squared I factored out, and that left me z squared in the parentheses. Now I'm going to look at the second set of terms and do exactly the same thing. Look to see if I have anything in common. And I have an m here and an m here. Bring out a positive m. I have that in common. I knew I wanted to bring out a positive because this sign here was positive. My sign here was positive. I knew I wanted a positive in my parentheses, so I didn't need to worry about changing a sign. So now I've got ym divided by m. That leaves me y. Bring down my plus sign. Z squared m divided by m gives me z squared. And now remember, what I need when I'm doing grouping is to end up with exactly the same thing in both sets of parentheses, because now I'm looking at the two terms I have left. I started out with 4 terms, now I'm down to 2 terms, and I'm looking for the greatest common factor of those 2 terms. Well, the greatest common factor is y plus z squared, so I factor that out. And when I divide y plus z squared times x squared by y plus z squared, what's left, of course, is the x squared. Plus, I do the same thing, this term, m times a quantity y plus z squared, divide out the y plus z squared that was in common, and you're left with an m. Or you can say it's what was in parentheses gets written down first. What was left outside of the parentheses is the second term. And now, because I have 2 terms left, I want to just double check that in each of those parentheses I don't have a difference of 2 perfect squares. Well, they both have plus signs in them, so they're not a difference of 2 perfect squares. They don't have a GCF left in the parentheses, so that means I'm finished. And to double check that, remember, you FOIL them back out. Sometimes if you move your terms around, when you FOIL back, you don't get them in the same order as your original problem, but as long as you have all of your terms, it checks. Okay, looking at number 9. First thing I ask myself in every factoring problem is, do I have a GCF? And I do. 2 divides into 162, so I factor that out. That leaves me x to the 4th minus 162 divided by 2 is 81. Next thing I do is count my number of terms. I have 2 terms left in the parentheses, so that means I'm checking to see if it's a difference of 2 perfect squares. X to the 4th is a perfect square because it has an even power, and 81 is a perfect square. Its square root is 9. So I bring down the 2 that I factored. I have 2 sets of parentheses when I'm doing a difference of 2 perfect squares. I take the square root of the first one. The square root of x to the 4th is x squared. I divide 4 by 2 to find out my my square root. If that had been x to the 6th, I would have said 6 divided by 2 is 3, and it would have been x cubed. I put that x squared in both parentheses. I take the square root of 81, which is 9. I use a plus sign and a minus sign in either order, doesn't matter. And so now, again, remember, once you have done what you think to be the factoring, check in each set of parentheses and see if there's anything else you still can do. Well, I look at x squared plus 9. That's a sum of perfect squares, so I know that part right there is prime. Then I look at x squared minus 9, and uh-oh, that's still a difference of 2 perfect squares, so that still needs to be factored. It factors to 2 binomials. It becomes x plus 3 and x minus 3. I bring down the x squared plus 9 that I didn't yet use, and I bring down the 2, and now everything is fully factored, and that's my final answer. I checked each set of parentheses. There was nothing else I could do, so that's my fully factored form. Okay, I believe I've done one of every type of factoring for the factoring strategy. And that'll be the end of the videos on the factoring strategy. Be sure to check one on how to factor the sum and difference of cubes.